Here from At Home Tuition. In this video, we are going to see few examples on how to find whether the given variables or the given function are in inverse proportion. The first example is observe the following tables and find which pair of variables. So here x and y are in inverse proportion. So we are given with three tables. The variables in all the three tables are x and y, and we want to find out of these three tables which are all the tables in inverse proportion. Now let's do one by one. Let's take the first table. So the variables given in x are 50, 40, 30 and 20, and the y are 5, 6, 7 and 8. So now let's quickly brush up what is inverse and direct proportion. So in direct proportion, we know two quantities are related as x is proportional to y. But in inverse proportion, the two quantities are related as x proportional to 1 over y. So in direct proportion, x by y ratio should be constant. In inverse proportion, x into y ratio should be constant. So we'll see in detail what is inverse proportion. So when two quantities change in such a manner that if one quantity increases, the other quantity decreases and vice versa, or if quantities are related in such a way that increase in one quantity leads to a proportional or corresponding decrease in the other quantity. So such variation of x and y we will call it as inverse proportion. So with this concept, we are going to check all the three given tables. So now let's rewrite the first table with the values as x1, y1, x2, y2, x3, y3 and x4 and y4. So it's easy for us to check whether they are in inverse proportion. So we know the relation for inverse proportion is x into y. The ratio should be constant for all the values of x and y. So now let us test. So x1 into y1, that is 50 into 5, which is 250. Next is x2 into y2, 40 into 6, which is 240. Then next is x3 into y3, that is 30 into 7, 210. Then x4 into y4, that's 20 into 8, which is 160. So these are all the ratios we have found out. So if you see all the answers, they are all different, not equal. 250, 240, 210 and 160. So they are not equal. So therefore we can say the given relation x and y are not in inverse proportion. Next we'll see the second table. So this is the second table given. First step, we will rewrite the given table in terms of x1, y1, x2, y2, x3, y3, x4, y4. So now we want to check whether these x and y are related in inverse proportion. So how we will check inverse proportion? X into y should be a constant value for all the values of x1 and y. So now x1 into y1 is 100 into 60, that is 6000. x2 into y2 is 200 into 30, that's also 6000. x3 into y3 is 300 into 20, that's also 6000. Then x4 into y4 is 400 into 15, that's also 6000. See here all the values of x and y are constant. They are all same. So therefore we can conclude that the given relation x and y are in inverse proportion. Now we'll see the third table. So as usual, first we will rewrite the given table in terms of x1, y1, x2, y2 and so on till x6 and y6. So now we want to check whether all these relations are in inverse proportion. So how we will check? X into y should be constant for all the values of x and y. So x1 into y1, that is 90 into 100, 900. x2 into y2, 60 into 15, which is also 900. x3 into y3, that is 45 into 20, which is also 900. Then next is x4 into y4, 30 into 25, so which is 750. Then x5 into y5, which is 20 into 30, that is 600. Then x6 into y6, which is 5 into 35, which is 175. So if you observe all the answers, we have 3 answers as 900, but the other 3 are different. So they are not same. So we can conclude that the given relation x and y are not in inverse proportion. Now we'll see one more example. Which of the following are in inverse proportion? So they have given with 2 questions. We'll go one by one. So we know what is an inverse proportion is. That is, if one quantity increases, the other quantity should proportionately decrease, or it should be a vice versa. Now let us see what is given. The number of workers on a job and the time to complete the job. So if the number of workers on a job increases, then the time required to complete the same job will be decreased. So increase in workers decreases the time required. So one quantity increases, the other quantity decreases. So hence we can say the number of workers on a job and the time to complete the job is inversely proportional. Next question. The time taken for a journey and the distance travelled in a uniform speed. So if the time of the journey increases, then the distance travelled will also increase. Or if the time of the journey decreases, then the distance travelled will also decrease. So here one quantity increases, the other quantity also increases. Or if one quantity decreases, the other quantity also decreases. So we can conclude that the time taken for a journey and the distance travelled in a uniform speed is not inversely proportional. They are not in inverse proportion. Hope you have understood. If you are given with the table, how to check whether they are in inverse proportion. So we have to take various values of x and y, that is corresponding values of x and y, and we have to check the relation. X into y should be a constant for all values of particular x and y. So next, in this case, the increase in one quantity should give a proportional decrease in the other quantity. So in these cases, we can say that the given relation is inversely proportional. Thank you for watching this video.